Okay, so let's take a look at graphs of equations, and specifically graphs of equations now in 2 dimensions. So the first thing is to consider a difference between solutions of equations and graphs of equations, how they're different and how they're related. All right, so first, a solution of an equation in 2 variables x and y, what is that? It's a pair of values for x and y, one for each, which make the equation a true statement. That's not surprising because that's what we said about equations before, that when we were talking one variable, that if we had a value of that variable that made the equation true, then it was a solution. So same thing here, it's just we have an x and a y. So, for example, the pair 1, 3 is a solution of y equals 2x cubed plus 1, since 3, the y value, is 2 times the x value 1 cubed plus 1. So now what about a graph of an equation in 2 variables x and y? Well, what that is actually a visualization of all the solutions to the equation where each point represents a solution. All right, so if we go back to what we were talking about before, the y equals 2x cubed plus 1, so this red curve there is the graph of the equation y equals 2x cubed plus 1. Now we haven't shown how we got that yet, that'll be coming later, but let's just assume we have that. Well, there is the point 1, 3 lying on the graph of that equation because 1, 3 is a solution to that equation. Note that if we took another point, say here is 0, 1. 0, 1 is a solution to this equation because 1 is 2 times 0 cubed plus 1. So that's why 0, 1 is on the graph. So a good question is, how do we get the equations of these graphs? I mean, the graphs of these equations. Sorry, that was backwards. All right, so one way we can think about it is we can just think about plotting points. Now, this is not a very elegant way of doing it, but it goes to a principle of what we're doing and what it means to be the graph of an equation. So imagine that we just pick a bunch of values of x and we calculate the values of y that we would get. So I'm just going to pick like a -3, -2, -1, 0, 1, 2, 3. So just a sampling of some negative points and some positive values of x and 0. And then if I went and figured out, so if I did x squared minus 2 for each of these, so -3 squared is 9, minus 2 would give you 7. -2 squared is 4, minus 2 would give you 2. And then I would get -1, I'd get -2, I'd get -1, 2, and 7. And what this really tells me is that I've got all these points on the graph. I've got -3, 7, -2, 2, -1, -1, 0, -2, 1, -1, 2, 2, and 3, 7. So if I'm trying to think about what the graph of y equals x squared minus 2 is, then I actually know that it has all these points on it. So if we wanted to, we could just set up a grid here. So let's say 1, 2, 3, 4 in x, -1, -2, -3, -4, 1, 2, 3, 4, 5, 6, 7. We're going to need a few more values there. Let me bring that down. And -1, -2, -3, -4 there. All right, so -3, 7 would be about there. -2, 2, -1, -1 would be about there. 0, -2, 1, -1, 2, 2, and 3, 7. And so I can start to see that the graph here might look something like this. All right, so I don't know exactly, but that seems like a likely look to the graph here. So that's what I've gotten just by plotting the points. I can get a basic idea of what this graph should look like. Let's take a look at some important features of the graph. And two important features are the x and y intercepts. Now there's a pretty easy way to remember how to get these. If you want the x-intercept, you're going to set y equals 0 and solve for x. If you're going to get the y-intercepts, you're going to set x equal to 0 and solve for y. Because if we think about a graph, then an x-intercept is when the y value is 0, and a y-intercept is when the x value is 0. So if we want to get the intercepts of the equation y equals x squared minus 2, so if we wanted the x-intercepts, set y equal to 0, x squared minus 2 is equal to 0, so x squared is 2, and x is plus or minus square root of 2. So that would give us the points square root of 2, 0, and negative square root of 2, 0. If we wanted the y-intercept, we would set x equal to 0, and then we'd get y equals 0 squared minus 2, or in other words, y equals 0. I'm sorry, that would give us y equals negative 2, and that would give us the point 0, negative 2. So there are the x-intercepts and the y-intercept. And if we go back to the previous picture, we see that here is the x-intercept. And so what we actually know now is that's radical to 0, and that makes sense because radical 2 is about 1.4-ish. And there is negative radical to 0. And there is 0, negative 2 as our y-intercept.